how can power delivery on a USB, a tiny USB connector and charger and system, can deliver 240 watts? To put this into perspective, if you remember these light bulbs that at the time deliver a very intense beam of light, and they dissipated so much heat that you cannot put your bare hands on the glass here without getting burned. Well, these devices generated and dissipated, and more on that later, 150 watts, and compared to 240 watts, that's 60% more. And this thing use household wires in 110, 120 volts or 240 volts in other parts of the world. Well, that wasn't questionable. How can you 150 watts is not questionable here, but 240 on something so tiny, how does power delivery is capable of doing that? Well, power is simply defined as the voltage times the current. And the current is only one current. I mean, if these are the source, either a battery bank or a 110 or 240 things that you connect into the grid, the current is coming from here all the way there, meaning that it's going to be generated and dissipated over all the components, particularly on the cable. We're going to be talking more about that. Well, we also know from Ohm's law that voltage is current times the resistance. If we replace the V here on this equation, we get that power is square of the current times the resistance. And why do I put the formula in that term? Well, to achieve 240 watts rather, we need to either increase the voltage or increase the current. Well, the problem with increasing the current is that, as you can see here, the power dissipated for the device that is generating, passing through, or consuming. If you double the current, you're going to be quadrupling the power that is dissipated. So this thing is going to get too hot. So while you want to get the P of power high enough, you cannot do it simply by increasing the current. What's the limit on the current? Well, looking at this equation, we see that that also the power dissipated to the device has a lot to do with the resistance. And the resistance is the resistance of the wire. You can either increase the diameter of the cable, which is not practical because you want to keep these things tiny and portable, or reduce the intrinsic resistance of the cable. But in the case of copper, there's not much you can do. We'll talk more about that later, about the devices that are used in here that gets resistance much smaller than the actual even copper wire that we use today. So in today's USB-C standard, typically the max that you can go in the current with this size of wire, of copper wire that we want to keep small, even with the best of quality, the most you can achieve is actually 5 amps. Well, how do if I'm limited here on the I, well, maybe I can increase the V, and that's how power delivery gets where we want it to be. We'll see that power delivery can bring this voltage as high as 48 volts. And then if we multiply that times 5 amps, we get to the 240 that is currently, at the time of this video, is the max that you can get through on USB charger. And why is it's so important to get high power? Well, you want to charge these devices, the laptop, whatever it is that you are using. You want to charge it the fastest, and for that you need to deliver to it the highest power that you can, dissipating the least amount of heat that you can as well. And that's what power delivery in the USB-C format can do for us today. So power delivery is kind of a little bit of a menu dance in which the device that wants to receive all that energy need to ask through the cable that goes across either the power bank or the USB-C charger that you plug on the wall. It needs to say, well, uh, can you deliver to me 240 watts or 60 watt or 100 watts, or what is the options that you have? So there is a protocol that goes on their power delivery that basically makes this device that is about to consume the amount of power to query the battery bank or the USB charger for what is it that you have available for me. And then it will tell, well, okay, out of that list of things that you have available, please supply that option. But the most important piece on that dance is the actual cable, because not all cables in USB-C are the same. And for that, I would like to recommend, none of the stuff that I talk about here is sponsored at all, is cable tester. This is the price that I got, at least from the US. And this little device allows you to determine what are the capabilities from many aspects that the cable that you're using can support. And the way to use this device, this tester, is by connecting the cable on the test from this end, and in here you have also other options like USB-A and micro USB, etc. And in here you have USB-C. This unit, you can charge it by, actually has another USB-C connector, but it's only for charging, but you can run it from a battery. So again, you connect whatever. I have a very short cable. This is my best cable that can do high speed and high power. You connect it there, and then you turn a little on-off switch here on this side of the tester, and the first screen that you are welcome is this one. That tells you a lot of things. Let's briefly talk about the data transmission. This is really the speed that this cable can is able to transfer data, let's say from an external USB-C drive and a computer or whatever are the devices. And the speed is determined by these 3 bolts on the top. Briefly speaking about that, this says, well, this cable can transmit data from one to another. So if you don't have any of the bolts in here, well, if you don't have the first one, you wouldn't have the second and third. But not having any capability here is actually not a bad thing, because if you want to use a cable on an airport or any place and you want to make sure that it doesn't get hacked, but that's the cable that you want. You want a cable that can give you power, which is this part over here, but that cannot transmit any data. But if you do want to transmit data, you want to have the speed is determined by the protocol that your cable support, whether it's 2.2, 2.0 or 3.2. And you can achieve 20 and even 40 gigabits per second with higher protocols these days. But again, we are talking to this power aspect of the power delivery. So the first thing that you can read, if you have only one ball here, that indicates, well, you can basically do 5 volts and 1 amp. 5 watts of power, very little, or maybe 5 amps, 5 volts and 2 amps. That's typically the most that you go around that. But then there are these 2 other protocols, which are 3.0 and 3.1, and more on those later. And this basically indicates that you can scale these up. And 3.1 is the one that allows you to go 100 watts and higher, up to 240 watts. Now, if you press a little white button that is on this side of the unit, you get to the second screen. This screen may look a little geeky, and it is. Basically, it tells you all the pins that exist on the USB-C connector that in this particular cable that I have attached here actually has a physical connection. And this is a very extensive list, but you can have one that has much fewer of these cables being actually used. But if you want high speed of data transmission as well as high power, you need to see something like this. But this is not the most important screen. Let's keep going. Let's keep pressing the little white button here and see what the next screen is. This basically tells you that the resistance, remember we were talking about power equals I squared times the R. Well, this is the resistance of the actual cable. This is a very short cable that I have in here and has only 49 milliohms. Okay, not even close to 1 ohm of, which is remarkably good for a cable, right? And it actually tells you that this is not really relevant, is that the ground is connected to the case of the actual USB-C, to the metal part of the USB-C is connected to ground. Let's click on the white button and see what else do we see here. This screen talks about an E-marker. What is that? For a USB cable to deliver or to pass through levels of power higher than 60 watts. If you want to go above this, you need to have in the actual ends of the cable a particular chip that is the E-marker chip. You see, when you connect the USB-C connector to your laptop, immediately after the laptop there is a chip called the PD, or the power delivery chip, which is the one that is going to initiate that protocol, that, or tell me how fast can you, how much power can you deliver so I can charge my battery faster, right? Otherwise, you will sometimes, if the power that you are supplying to the laptop is below what is consuming for operating, you're draining the battery even though you are connected, and you don't want that. So that E-marker chip is the one that is at the ends of both cables, and is the one that supports such a negotiation. But any good cable that again can go around 60 watts, and typically this goes around 100 watts. Any of those cables needs to have an E-marker chip. Also, the power source needs to be able to deliver such a power. More on that later. But let's go back to that screen that I showed you before on the E-marker chip. So in here we see that there is the presence of the E-marker chip. Otherwise, you get a screen that says no E-marker chip has been found. And notice that in here it tells you that it can deliver 50 volts at 5 amp, right? So that's the maximum capability that it has. Actually, that's a little over 240 watts. And here you can actually read, this is the max that this cable will support. There's also an information about the speed of the cable, but we said that we are not going to be focusing on the actual speed of the cable. You got a vendor ID number, etc. But this is the piece that you want to understand how good your cable is for supporting that power transfer. Because you need the three things in here. You need to have a device that is going to demand the levels of power, and of course supports that negotiation of PD. You have to have a cable that is capable of making that through, and you need to have a power source that can deliver that, right? And we can see here one from Anker, one from Ugreen. This power bank can deliver 100 watts, and this one can deliver 140 watts from the wall. And the reason I put those two brands is that, at least in my case, I don't buy chargers that are not from reputable brands, because these things, particularly the battery banks, have lithium batteries. You don't want this to be a fire hazard. So I think it is best for you to actually buy power sources and checking your cable, you know what you are talking about. How do you know? How do you translate these 140 watts and 100 watts? Exactly what does that mean? So well, you need to look at your reputable power charger, get a good source of light and maybe a magnifier glass because these characters are very tiny. But in here you can see that in the USB-C, the C1 typically is the port on the top, C2 is the port on the bottom. It tells you the dance that it can play on that menu. For example, it can do 9 volts and 3 amps, 12 volts and 3 amps, 15 volts and 3 amps. And here's the 20 volts, 5 amps, which gives you the 100 watts that you can deliver. And also specify that, well, I can only deliver that much when I only have one connector put in there. I mean, if you have more than one, that power delivery needs to be shared. But this is probably the most important thing that you need to understand in order for you to see whether your device is taking advantage of the whole ecosystem from the wall all the way to the laptop and see that you are getting the most power, so you're charging your devices the fastest that you can. And how do you actually see this in action? This little and inexpensive device can actually tell you what voltage we see here, that is 13.7 and 3.9 amp, and you connect this device in series. Let's say that you connect it at this end, so from one end to the cable, the other to the laptop, or from one end. Actually, I don't think it is bidirectional, so you probably most likely will connect it at this end to see, whether you are getting those 5 amps and whatever voltage that you're getting. And again, you need to make sure that this device is discharged enough and capable enough to negotiate or to ask for that. You have seen the capabilities of your cable already, and you have read what the labels of your different power sources can deliver, and then you can verify that, okay, these things are working precisely the way I want it to. And because of USB-C and power delivery is that you probably very seldom will keep on seeing this wall being offered anymore, because they are noisy in terms of electronic noise that they can generate. They dissipate. They are less efficient than the USB-C is, and they're bulkier, etc. So there's no reason for having this, and they're all fixed voltage, while the USB-C can give you a menu of voltages and currents that you can take advantage of. And if you're inclined to play with electronics and you want to learn more about USB-C PD, or you want to know, validate, for example, that little letters that you see on your charger, are they really capable of doing this and that? Well, there's this little device. This is from the people of Adafruit, and this is the part number. We can see it here. And what this device does is you can connect a USB capable, power source. Let's say that you want to validate that your power source that you bought that says that is 140 watts. Well, can you deliver that, or whatever is the wattage that it says? And you can get at the output here whatever voltage you want. This is the negative and this is the positive, and you can use this as a power source for a motor or whatever, LEDs or whatever you are using, and you can determine what voltages you are going to get in 2 ways. One is by flipping this micro switch that we see here, and then that allows you to say, well, give me 5 volts, 9 volts, 12 volts. We can actually see those voltages there, right? But most importantly, you can have any, let's say, Arduino code, and these people provide you the libraries and the examples and all that. So you can have your Arduino C++ program basically asking this power source, okay, show me what you are capable of. And that's a very good way of validating that power source that you have is that good. It can only go as high as 20 volts, so you will not be able to do 240 watts. because for that you need 48 volts. But you can go as far as high as 100 watts and determine, whether that power source that you are buying is good enough for that. In fact, I connected that to an Arduino and I used the library that these people provided. And the example is this try all voltages.ino, and it basically tells me, okay, this unit can do 5 volts, 9 volts, 12 volts, and you can see in the documentation the people from Adafruit are very good at providing all the details in a PDF. I believe that this module can go to 3.1 3.12 amps and there is a switch that you need to solder in the board, but you get all the details in that document. But this is a good way for you not only to see it in action, but have your mechanism for, okay, getting a little geeky here, but you can make sure that the power wall that you, or the battery bank that you are buying is actually capable of meeting those little letters that you saw of the protocol that is capable. But if you're buying something from Anker or Ugreen, you can take that to the bank, so to speak. And I hope that this video gives you a better understanding of the power of USB-C power delivery.